Okay, some of you have asked about the exercise 14D1, and I'm going to start by explaining this to you, okay? We cannot go there without knowing this. The first thing we have to know is that when we multiply and divide integers, and if they have the same sign, if they're both green or they're both red, the answer is going to be positive. If they are green and red, the answer is going to be negative. Or if they're red and green, the answer is going to be negative. This means same color, same sign. Same color, same sign. If you're multiplying same signs, the answer is going to be positive. If or dividing, multiplying or dividing. I don't see any division symbol here, but I think this helps a little. And these are the examples. You are multiplying the same sign. You see, multiplying the same sign. The answer is going to be always green, always positive. Or you're dividing the same signs. The answer is always going to be green or positive. The same thing happens when you have different signs. The answer is always negative or red, negative or red. Why do we even care about this? Because we're going to use it here. And the first exercise is asking in the first exercise they're asking you to convert between this and the general form equation of the into the general form, which is another equation of the line. So we know lines, so I'm going to write it here. Lines, they go like this, right? With arrows. They can have different slopes or gradients, and that means the steepness or directions or guided directions. And I'm going to show you that later. Okay, and they have many. We can find them in many ways. One of them is the one we know, which is also written like this in some books. So this is the gradient intercept form, because you see the gradient, the m, whatever is multiplying x, that is the value of the gradient or the slope, and whatever is alone without y or without x is going to be the y-intercept. And there is another name of the line that we learned, and it was ax plus by equals d. Why not c? I don't know. I like to do it like this: ax plus by equals c, because I think this makes more sense to me. I don't know, but okay. Well, we are going to start converting between the two of them, from this to this. Okay, the first thing we have to identify is either if we have the equation in the blue form or the orange form. In this case, all of them have y equals. Y equals means that, okay, that I have the blue form. So I have to turn that into the orange form. So the orange does not admit fractions. That is the first thing we need to know. I'll start with this question. Yeah, I know I'm going to solve it, but whatever. So question A is y equals 1 over 2 x plus 3. And we need to turn that into one of the green of the orange, sorry, the orange way. How do we do that? The first thing we have to do is to get rid of the denominator. What is the denominator? The number in the bottom. This number 2 is the denominator that we want to get rid of. How do we do that? I'm going to rewrite the blue equation again. 1 over 2x plus 3. And then I'm going to open giant parentheses in yellow. So I'm going to open parentheses here and a giant parenthesis here. Why do I do it on both sides? Because, yeah, I only have y on the left, but I want to show you that no matter the number you choose, you're going to multiply everything on the left side. Everything in blue on the left side is inside of the yellow brackets or parentheses. Everything in blue on the right side is inside of those yellow brackets or parentheses. And I'm going to multiply that times 2. This is no coincidence. This is no coincidence, because I know that when I multiply these two times this fraction 1 over 2, I'm going to cancel the denominator, cancel these two in the bottom. But I'm going to show you that step by step, so don't be afraid of this, okay? So I'm going to solve the one on the left first. When you multiply a number times a variable, you keep the number and the variable. So it's just 2y. Why am I turning this orange? Because it's starting to look like this. I have the number that, or one of the numbers that because I don't know the sign yet, okay? But so far, I'm getting B, something that multiplies Y. So it turned orange, you see? So the part on the right side is still blue. But I'm going to separate that number 2, the orange, and I'm going to multiply it times 1/2x and the number 2, again, times 3. Why? How is it possible for me to do that? Because this number 2 multiplies this, and that thing goes here. I'm separating everything so you can see it one by one. This part goes here, but then this number 2 multiplies this positive 3, and I'm going to separate that here. Okay, so 1/2, your positive 3. This number 2 was positive, that's why I put this positive here. The thing now is that I have to solve this part, and this is the most complicated one sometimes, okay? Why? Because we have a fraction, and sometimes we're afraid of fractions, so I'm going to do it on this side. I have a number. If I have a number, and I multiply that number times a fraction, in this case is 1/2, what do? I have many options, but if you only have one number on the left, you multiply it times your numerator and you keep the denominator. You keep the number in the bottom. How does that work? Okay, 2 times 1 is 2. The black 2 in the bottom stays there. And then if you can simplify, you simplify. Why is it possible for us to simplify this in this case? Because I intentionally multiplied everything by that denominator, by the same number in the denominator, so I could get rid of that. How do we get rid of this? Because this works as a division. And then you can say 2 divided by, the green 2 goes inside of the division symbol. So it's 2 divided by 2. This is how the fractions work. This is the division way, division, and this is fractions. Okay, so you have to look for a number that once you multiply times the black number 2, you get 2. Obviously, for us, that number is 1. Okay, so 2 times 1 is 2. Then you can subtract these ones and the answer is just 0. So you know that you got the right number here. Your answer is 1. 2 divided by 2 is 1. Another way to see this, a faster way, because I know I took the long way to explain this to you, is that you say you have the same thing on top and the same thing in the bottom. So you simplify them and the answer is 1. Why? 6/6, 1. And 500 over 500 is 1, because this is the thing that is going to happen. You're going to have a 500 here, 500 there, then 1 is the number that you have to use to multiply 500 to get 500. You see, so you could have a monster, like I was saying in class, or something like this. This is not a monster. And you divide it by the same thing, the answer is 1. So don't be afraid of this. If you divide by the same thing, the answer is 1. That's how you simplify. Okay, so once you do that, you're multiplying the number times the other number. And you remember what happens when you multiply a number and a variable? You keep the number and the variable. So you get 1x. Now the x is in orange because it's starting to look like this. We already have ax or something similar to that, right? I'm going to erase this number 1 later because I don't want to leave a number 1 in front of any variable, because if the variable is alone, it means that you have a number 1 in front of that 1, 1. You see? If your variable is alone, you have a number 1 in front of it. So I'm going to erase this part. Okay, and then the easiest part. Why did I show you that before at the beginning, the multiplying and dividing integers? Because these rules apply here. Look at this. Well, actually, they apply everywhere. Here you had a positive 2 and a positive y. Remember, positive times positive gives you positive. It applies everywhere. So it is positive, but you never see it because it's positive. And we don't have any negatives here, so all the answers are going to be green, positive, positive, times positive gives you positive. And in this case, your positive times positive, positive. 2 times 3 is 6. And now that 6 is orange because we're transforming this. And I'm going to get rid of the blue thingies here. And they're going to become orange. What I have to do now is to rearrange this so it looks something like this. I leave the 6 on the right side because I need to have a number on the right side, this C, without any letter, okay, without any variable. So what do I have to do? I know that something that is multiplying X goes first, and the thing that is multiplying Y goes next. So I leave that 2y close to the equal sign. I leave it there. I know it's positive, so I leave the positive in front of it. And this positive 1x is going to turn negative if I take it to the other side. Because this equal sign to me is like a bridge. So if you have a bridge, forgive my drawing, please. And you have a number on the left, and this number is positive. Once the number crosses that bridge, what bridge? Blah. Well, you know what I'm talking about, right? It goes to the other side. I should have done it in green. I'm sorry. This is green, is positive, and it goes to the other side and it turns negative. Whatever is positive on one side, it walks here. It was supposed to look like shoes. Well, not shoes, but shoe prints or whatever you want to call them. You go to the other side and you turn negative. You change the sign. In this case, you're going to say, but why? You have a 1 and you have the x. But I told you, remember I told you that if they're combined and there's no sign positive or negative between them, it means that they are in one basket. So it's only one thing. So yes, you take the whole thing to the other side. So this blue positive is going to turn negative, and it's still your 1 and your x. All right, we got it. This is it. Now, this looks so horrible that I'm going to rearrange it. I'll get rid of this number 1 because remember, you have a number 1 in front of something and it's the same something if you're multiplying it. So my final answer is going to look like this, minus, because I need to give the minus because it belongs to 1 and x at the same time. So it's going to be just minus x plus 2y equals 6. And this is how we turn blue into orange, into gold, into the general form or general or standard equation of the line. This is it. So you can identify your values. A is the number that is multiplying x. So in this case, minus 1. Why minus 1? Remember what we did before? So yeah, if you have to say or you have to tell them, okay, what the value of A is, you take it here. B is positive 2, but you don't write the positive because it's positive. It's obvious. So C equals 6, okay? And this is how we do it. This is how you do it. Okay, oh, I should edit that, but I don't know. Okay, now let me erase this part and let me show you how to do the opposite. How to go back. Oh, you know what? What did I do? I was supposed to erase this. There you go. Okay, now let me go from this to that. Let me show you how to go from the orange to the blue part. Okay, I'm going to get rid of this. And I'll get rid of this. I hope this is not taking too long and you're not too bored, but okay. Now let's say we have minus x plus 2y equals 6. How do we turn this into the blue part here? How do we turn blue? The first thing you have to realize is that you don't have any fraction. The second thing is that you have two terms here and then y is not alone. That is the first thing. So what do we want to do? We want to start leaving y alone on one side, on the left side, and positive. Well, yeah, it could be on the right side and positive, but I prefer it to be on the left. That's it. So I'm going to do the reverse, or the inverse, sorry. I'm going to do the inverse of what we did here. Yeah, because we want to turn it blue. So the 6 stays there for a second. I'm going to get this x, this negative 1x to the other side. Remember, I take all of this and it turns positive, so positive x. Then I have a 2y on the left. But you know what? I want to get rid of that number 2. If I want to get rid of this number 2, I have two options. Either I take this number 2 down, dividing everything on the other side, like this. I take it down and dividing everything to the other side, or I don't do that. Let me go back. And I divide this by 2 because I want to get rid of this number 2 because of the fraction I showed you earlier. You simplify them. 2 divided by 2 is 1. And how can you cancel them? Because on top you have only one term. If you had a positive between the 2 and the y like this, 2 plus y divided by 2, forget about it. You cannot do this. You can't do this. They have to be in one basket. Here they are in different baskets because there is a sign between them. So they have to be in the same basket for you to do that. So 2 divided by 2, and then this 6 is going to be divided by 2, and then this x is going to be divided by 2. Okay? And that's how you cancel these 2 with these 2, and your y turns blue because it's staying alone on the left side. And then what do you have on the right side? You can simplify this 6 over 2. How do we do that? Yeah, I told you I was going to do it step by step, even if it's not, I don't know, fast or anything, but yes, 6 divided by 2 goes like this. I'll show you two ways, okay? One of them is saying 6 divided by 2. Yes, I know you can plug this in the calculator, but what if you can't? That's why I show you step by step. So 6 divided by 2, you look for a number that when you multiply by 2, it gives you 6. Yes, 2 times 3 is 6. And that 6 is going to be purple here. Now you can subtract them, and if the answer is 0, you got it. This is your number. So that's how you simplify it, and that's your 3 that goes here. The other way is to say that your 6 is also a 2 times 3. Okay, I'm going to erase this part. Erase, erase, erase. Takes me too much time. Okay, now what if I didn't do it like that? I didn't want to do it like that. Okay, what you can do is to say 6, you can rewrite it as 2 times 3. And you have the denominator, which is 2. I'm only changing the way it looks like. I'm only changing the way the 6 looks like. But the orange 2 and the orange 3, if you multiply them, gives you the orange 6, okay? In this case, remember, I don't have a positive or a negative between the 2 and the 3. It only applies when you don't have a positive or a negative between the 2 and the 3. If that happens, you can simplify the 2's, and your only number left is 3. If you don't like it this way, then do it the other way. Just divide them, okay? But this is a good way for you to simplify fractions. So you do it the way you prefer. I showed you both of them. If you don't believe me yet, let me know and I'll record another video just for you to see if it works. Now everything is starting to look like the slope intercept form. But the thing is that in the slope intercept form, x goes first. I have two terms on the right side, one term, another term. Why can I say that? Because they're in different baskets. Why are they in different baskets? Because there is a sign, positive or negative. In this case, is positive between them. That's why. So I'm going to switch them, rearrange them, and I'll say that y equals positive x over 2, positive 3, because this 3 is positive, and I'm not crossing that bridge. I'm still on the same side, on the right side of the equation, okay? And y can also be written as 1x over 2 plus 3. Wait a second, why did you do that? Okay, look. Remember I told you that even if the letter is alone, that means that it's a number 1 multiplying it? So yes, you can say that you have a number 1 multiplying x. And then you have your number 3. I didn't expect to erase everything, but yes, x over 2 plus 3. And this is how I turn orange to blue. And this is how I go from the general equation of the line to the slope intercept form. And what if somebody shows this like this, 1 over 2 x plus 3? I would be telling you that is the same thing. It's the same thingy. You know why? Because you're multiplying 1 times x and you're dividing it by 2 because you're multiplying this. So whenever you multiply two things, let's say you multiply 3 times 4 over 7, plug this in the calculator. It's going to give you 12 over 7 and then whatever it is, right? This is the same as saying 3 times 4 and dividing by 7. I bet it's the same thing. And it's going to give you 12 over 7. What it doesn't matter how you plug in the calculator. So one step at a time, you can say 3 times 4 and then you divide it by 7. And this is how it looks like. 3 times 4 divided by 7. Or written graphically, visually, you can say 3 over 7 times 4 is always going to give you 12 over 7. Why? Because the number 3 is being divided by 1. In this case, you multiply the numbers on top and you get your answer on top. You multiply the numbers in the bottom, you get your number in the bottom. That's how you multiply fractions. Wait a second, I didn't have a fraction there. The number 3 was a whole number. Yes, it was a positive integer, I know that, but the thing is that you can put the yellow part, the fraction and the 1, because whenever you divide a number, by a number 1, you get the same number. So yes, you can assume that you can do it like this. Wait a second, what about this? You said that it was a number 1 below the 3. Yeah, but in the same way you can have a number 1 below the number 4 here. You multiply the tops and you multiply the bottoms. You see how no matter how you do it, 1 times 7 or 7 times 1 gives you it still gives you 7 in the bottom. So that's how we multiply fractions. There are 3 different options for you to see it visually. And that's how I explain this part, that your gradient, your slope, in this case, your m, is 1 over 2. One last thing. Here it's easy for us to identify the slope and the y-intercept. The y-intercept is just 3, okay? It's this number alone, positive 3, positive 3. That is the gradient and the y-intercept. What about this then? What happens when you have it like this? How do you identify the gradient? And this was something that I wanted to show you. And is that you are going to divide a over b. But what is, oh, I shouldn't have erased that. But you know, a over b, a is this number, minus 1. And your b is this number, 2. But you're going to change the sign. So if it's negative, you're going to take the positive, the opposite to that. And that is going to be your gradient of the line if you see it in general form. How does that work? Remember that you have it like this. Your gradient for the orange way is going to be minus a over b. That's what we saw in class. In the general form is minus a over b. This is with capitals if you have it like this, or if this is with lowercase if you have it like this. So yes, you can identify the gradient easily when you have it like this, when you have the general form of the line. Then to show you something else, I have the coordinate grid, and I'm going to plot this line. How do we plot lines? Remember, you start plugging numbers into the x, you start plugging numbers there, and you get your values in y. You plug numbers in x, I'm going to plug a number 2. You know why I'm going to plug a number 2? Because I want it to be divided by 2 to get rid of that. What? Look, y equals 2 instead of 1 over 2, x plus 3, right? So y equals 2 divided by 2, it cancels out, remember that. So it gives you just 1 plus 3, which is 4. So when you plug a number 2, you get a number 4. So your point is 2, 4. How do we plot it here? 2 and 4. That is one of your points. What happens when you plug a 0 there? Y equals x over 2 plus 3. Y equals 0 over 2 plus 3. What do you get? This is 0, so you only get a positive 3. When you plug a 0, you get a number 3. When you plug a 0 in x, you get a number 3. There. If you match these 2 points, you are going to have your line. Let me see if I can move it a little bit. You can draw your line. This line has a gradient of 1 over 2. How do we check that with the rise over run? Oh, I wasn't supposed to change the color of that. Okay. Rise 1 and run 1, 2. So your gradient graphically is 1 over 2. Wait a second. You drew a line segment. Yeah, I'm going to draw arrows here so you know that it goes to infinity and beyond. So you tell the person who's looking at your graph that he can continue up and down with your line. Well, I don't know if this part was a little bit confusing, but